DevOps architect is the global head of engineering transformation at L&T Infotech Limited. She has worked with Fortune 100 clients across manufacturing, BFSI, and telecommunication domain. Through her power-packed talk, she's all set to help us understand the various areas wherein AI can be used in our software development activities. Let's all welcome Miss Archana Joshi with a thundering round of applause. Over to you, Archana.
Good morning, good afternoon, and good evening, everybody who's listening in to the DevOps India Summit 2022. This is my fifth year of participation, and I've seen it grow year on year and increasingly handling varied topics, not just DevOps, but also looking at what is upcoming next in the IT engineering space. And one of the topics this year is artificial intelligence. And today I thought, let me pick up that topic and try and see how artificial intelligence, DevOps, Sdlc, all of that can come in together. So what I would be talking today is how do you exactly improve efficiency using AI? And essentially, I call it like it's like what I call as a meta programming concept, which means to write a code, you are using another piece of code, right? So essentially, that's how it is, a little bit matrix style. So let's delve into it. Before we go deeper into the subject, let me also give a quick introduction about myself. So my name is Archana Joshi. I head the IT strategy function within Larsen & Toubro Infotech. Prior to this, heading the strategy function, I've spent almost 12, 13 years in the areas of Agile, DevOps, and almost over 21 years now in the industry looking at varied areas, right from testing, development, support, and so on and so forth. And hence, increasingly, when I looked at how the whole IT industry has shifted from when I started way back in 2000 to today, it has shifted a lot in terms of how we are assembling our programs, how we are bringing our code together. It has also shifted in terms of the new technologies that have come, but in many ways it has not shifted also. And when I say that, I still remember in my engineering time, I had a book called Pressman, which was used for software engineering life cycle. And still that is, of course, a Bible for people who get started to understand processes, practices around software. But that got me thinking that while a lot of things have changed, a lot of things have not changed as well from a life cycle standpoint. We are still talking about different things. Of course, Agile is there, but fundamentally the steps of coding, designing, testing kind of remains the same. And hence, that got me thinking, saying, can we bring in the latest, greatest technology which is out there, which is artificial intelligence, and try and see if we can infuse some newness within the Sdlc lifecycle. So that's how the whole thought process was when I kind of wanted to talk about this topic in today's forum. And with that, let me just start off with a question, which is that how much code do you think we write? And we've written so far. Right. And it's a very tricky question. Of course, there's nobody I think can count it exactly, but there have been studies which have done where it's a fair guess, fair estimation in terms of what it would be. So on an average, if you look at the code, there is almost a shocking number which comes out, which is 93 billion lines of code are written every single year, which is huge. 93 billion lines of code. Of course, the saying today goes that every industry is a technology industry, is a software industry. And this number kind of substantiates that. But still, 93 billion is a huge number. When I just think of the number of data that it's carrying around it, the code that we are generating as software engineers. And if I say that 20 years back, since I started and the industry started gaining more and more traction, what would that be? So roughly 93 times 20, which is almost 2.8 trillion lines of code, which is 5 times the stars that are sized or estimated that we have in our galaxy, which is the Milky Way. So it's staggering in terms of how much code gets written, how much software gets written, and how much of it is consumed and how much of it is there in our day-to-day life. So if that is what the data shows us and some of the researchers are talking about it, let's go deeper into saying that how is that code written, right? And of course, I'm sure all of us are aware the SDLC, which is a software delivery lifecycle associated with it, which typically has 6 stages. And of course, if you are using iterative, agile, waterfall, any new one which is coming up, lead, etc., some steps and the order in which you do the steps would change. But broadly, these 6 are the areas where that writing of that code happens. The 6 steps are, first, of course, planning, which means what is that code for? What are you going to write it for? What are your requirements? What is the problem that you're trying to solve? Ideating all of that, right? And planning around it. So that's the first step. Second is all about analyzing to say, okay, what do I do with it? How do I go about writing it? Third is designing. And here is where your architecture and those kind of things, technology decisions start coming to play. Then, of course, comes the fourth step, which is the actual writing of the code and actual opening an IDE, the development environment, and going there. And then, of course, comes the testing, integration, and ongoing maintenance, enhancement of the software that you do. So broadly, these are the 6 steps that we have. Now, if you look at these 6 steps, so we know that 2.8 trillion lines of code have been generated over the past 20 years, almost 93 billion a year, through variations of these 6 steps. So, of course, it's not just the code that gets generated. Along with the code, we do a lot of things, which means that for testing, I would write test scripts. I would have test cases. I would have the test data. For planning, I would have the sprint plans if you're doing agile analysis. You have your design documents. You have your design decisions, implementation, coding, code reviews, analysis as further impact analysis, looking at what the changes are coming, right? Integration, APIs, all of this, maintenance, tickets, defects. So many of this data or the work that we do to deliver this is getting generated. So essentially, right from the data that gets generated, the documents that you might have written when you are doing the architecture, or the test cases that you have, your user stories, which has form of your starting point, essentially, right? Your tech debt analysis, which says how good, bad, ugly the code you're writing. Your number of builds if you're doing CI/CD, your defects, review comments, acceptance criteria, all of this data is floating around us. So if the lines of code itself is 93 billion a year, imagine the amount of data that's floating around this. I'm sure it's going to be much more than the number of lines of code. It's going to be almost 1.5 times, or even if we go by conservative estimate. So that huge data all around the software industry. And that brings us to the question saying that what are we doing about this data? We are solving the problem, yes, and the problem to be solved is for business problem for which we are writing the software. But while doing that in the process, there's a lot of data that's floating around. It's just sitting. Many a times we may use that data to do some analysis, metrics, do some things, but on an average, that data kind of sits in, it just sits. The testers may use some of that test data to say, okay, what should be my regression areas when I look at a new release? Or some of developers may look at the previous comments from a code and look at it. Or a support engineer may look at saying, how was this ticket solved? Or may use some of the previous data to do automation and bring in bots and all of that. But that is still in isolation, in silos. It's not something which is coming together to say, okay, if this is an end of ticket which is there, what does it mean for the user story that's coming up? And how do I use AI on top of it so that even if somebody is new in the system, they can understand what to do, right? There's this lot of data which is there. And are we truly leveraging the data to make our life as a software engineer better? That is lot to be decided. There's a lot more that we can do compared to what we are doing today. Hence, the questions or the pertinent 3 questions that we have to say that what can we essentially do with this data are, can we use this data to make less mistakes by engineering the code? Is there something that we can do? Can we use it so that I as a developer is nudged in the right direction to make lesser mistakes? Can I use this data to understand how my software systems are connected, interconnected? What do I exactly do? Can I use it? Today, if anybody wants to, and I've seen this many times, especially being in a service industry, IT services industry, whenever you have, as an IT service provider, have to take over an application for maintenance, the first thing that you undergo is a transition. which means talking to the SME, going through the code, understanding what has happened in the past so that you take it over and you understand that. And I'm sure all of us on the call would agree that just doing that doesn't really give you the nitty-gritties that are hidden inside the software. How is it connected? What happens? Why did it happen this way? What was the source when somebody took that decision to write a code in a certain manner or design it in a certain manner? All of this is kind of gets lost over a period of years. So can we use this data to understand the intricacies, the history that was there? Can we use this data to make general software delivery itself more efficient, right? And I'm sure the answer to all of this is yes. We can use it in bits and pieces today. We do use it, but are we truly exploiting the power that is there? Perhaps not. And hence, let's try and bring in the AI aspect. This is just a statistic again, which I came across, which says that AI, of course, is the hottest thing out there. Its growth is exponential. It's already supposed to reach a market size of nearly 1.6 trillion by 2030. And the growth rate is 38.1% of CAGR, which is huge. It's unprecedented the way AI is getting used everywhere. So why don't then we leverage AI to make sure the whole SDLC piece on how we ourselves are writing this AI software to solve business problem is used to make sure our IT is more efficient. And here are some case studies that me and my team have worked in the past. And when I say recently, over the past 2 years, where the first question to say that can we use this data to make less mistakes while engineering our code? So this was a case for one of our insurance clients, insurance provider. And of course, as you can imagine, any insurance company, their IT landscape is heterogeneous. You have all sorts of technologies. You will have COTS products like a Guideware, like a Duck Creek. You will have, of course, bespoke applications written in Java and .NET, and so many projects, some digital native projects going on for customer experience, some integration projects going on, some modernization activities happening. Pretty much you can imagine this going on in any large enterprise, right? So many projects, so many handshakes, in spite of having your all agile DevOps great practices, brings in certain inefficiencies when it comes to our ability to be efficient in certain things and engineering our certain things, right? While we have DevOps, which helps us shift left and make it early in the cycle, testing, automation testing, can we even optimize it further using AI? And so what we did was we looked at almost 100,000 defects. And when I say we looked at, it was a solution that was built is using AI. So there were some AI-led algorithms that we developed, and those were analyzed across 40 different projects which were running in the company. And based on the algorithms, the machine learning, plus a little bit of NLP that was there, that helped to reduce the defect detection and complete elimination of those defects by 20%. Now, this is huge because this is typically an IT spend. Even if you conservatively think for a company, let's assume 10% of their overall working capital is spent on IT, right? So if on an average we say a $1 billion company, you can imagine their IT budget to be almost 100 million. And out of that, if you look at the delivery work, almost 40-50 million of that would go on delivery and development work. Now, within that, if you are able to save 20%, reduce defects and eliminate them completely, all that money that you saved is going to help you and can move into more strategic programs and do better work. And of course, that's not just money saving. It also means that your entire software is becoming more and more robust because you're making less mistakes. You're removing those defects. You're early detecting those defects, right? And why this is possible? Because it's not just about defect that's coming in your area. Through this, your particular system may be connected to another system. So if you can look at their requirements, test cases, can develop a correlation, look at the architectural documents, bring all of this together, look at the tickets. And if you're able to correlate all of it, you can figure out where exactly the problems lie much easier. And hence, these kind of results can be seen. Similarly, this was for one of the largest government in the world looking at their tax programs. And essentially, saying that when you have these kind of big solutions, what does happen is that there will be a lot of requirements that come in. And as you can imagine, when you have government systems, there's a lot of stringent regulatory needs which need to be implemented very, very quickly. And then you have a lot of other needs in terms of making sure, especially in finance, making sure that the room for error is very less, because it could be a tax. And I'm sure if you get taxed more, you kind of feel that it's unfair to you and you would ask for a reimbursement from the government, right? So there's a lot of, I would say, nitty gritties that come in when you are designing these kind of systems. So the question that we had on the table was, when you have so many ministries, finance ministry, other ministries who are coming together to identify the tax, and tax could be an income tax of an individual, it could be a sales tax, goods tax, whatever, right? So when somebody says this is a new requirement that I have, can we also be able to do a certain impact analysis to say where exactly, if I introduce a user story, where in the software this user story impacts? And can I not every single time rely on an expert, because many times experts may not be available, they would have left the company? What do you do then? So in those cases, can you feed all of this data that's going on and let AI take the lead here and figure out those dependencies and tell you this is exactly where it will get impacted if in the future you introduce this kind of a change? So that's exactly what we did here, where we used all of this data of test cases, scripts, user stories, your acceptance criteria, all of the ones that I showed before, to figure out, say, if a particular change in a user story gets introduced or an epic gets introduced, where does it impact? And that helped us almost reduction in the effort by 15% to do the impact analysis. Of course, an expert is needed. We are not saying leave everything to the AI, because you should understand that AI also learns. So it takes time for the algorithms and the engines to understand what is going on. So the more data you feed, they want to give you better accuracy at the results that throw in. Until then, you of course will have to have a combination of these AI solutions coupled with the experts. So this helped us, where our experts were able to do much more with the time that they had and guide many more other teams rather than just looking at one thing. The third question, to say that can we derive insights to make our software delivery more efficient? So this was one more case where we had almost 20 agile pods. Across these 20 pods, 8,000 plus user stories. You can imagine the test cases, 24,000 test cases. Of course, they were all automated. So many lines of LOC. And here what was done was, we anyways had a CI/CD DevOps tool chain, but AI was applied within that, which means that when a code gets written, typically what happens, you check in the code, and if your CI/CD gets triggered, you say, okay, do a build, do a deployment, then do a test, validate that. If it's there, push it to the next staging or whichever is the next environment, higher environments, basically. That's how your CI/CD cycle is. Now, if you insert this AI, where AI engine that was developed to say, hey, if I check in a code before the build gets triggered, let this engine run to say this code is actually impacting where. So intelligently it will say these are the areas which gets impacted. And then when the build is run, you don't have to go and run entire regression suite or entire test suite for it. You just have to run the suite which is truly impacted by this code which is getting done. So which means you're not only saving on the time that the whole CI/CD completion cycle time, you're also saving on the costs associated with it. You're also saving on making sure you are not unnecessarily doing any work which yields no result. So your non-value-added activities, if you are familiar with the lean concept, also reduces. So this way, what you are doing is, within the CI/CD, you are applying AI on the code that gets written once it gets checked in before the build gets triggered to identify what exactly is the change that's happened. So this was one more area which helped us to reduce the cycle time of the CI/CD completion cycle time by 50%. So when I check in a code, if it's going to take me almost an hour to figure out and go through the whole cycle time of CI/CD and validate it, imagine the developer is getting that feedback much early. They can move on easily to the next user story that they have. So it's becoming more efficient, not just for the engineers who are there, but also for everybody else, the management and all of them who are involved. So I spoke 3 use cases where we were able to successfully implement this. But let me just dig a little bit under the hood and say what was used and what are the kind of things that get used. So I'm sure many of you who are a little bit closer and know about AI may know some of these things. So the transform models is something which is very actively used in these kind of solutions. Then you have the GPT-3, one of the popular AI engines out there. So you can leverage that too. What is more important? So while these engines exist, which you can leverage, what is more important is how you are able to correlate all this data. And that's where the ontology comes into play. To say, okay, if these are the kind of data sets, because your data is not just a code data, it's a requirement data, it's a test case data, it's a document data, it could be an image which somebody's drawn, right? And it's an image. So it's not just about English documentation, English words that you're interpreting. You're also interpreting an image, a design image, which could be there, a blog diagram, which could be there. So there are different sources that you need to interpret. So your ontology becomes very crucial on how you can do that. And then, of course, the correlation based on the ontology and the data, which essentially are your knowledge graphs. Because once you have these in place, these basic things in place, then it's, I would say, then it's almost like you've cracked the first step of this whole AI driven SDLC. Because after you get this, you can draw any amount of insights, slice and dice it, get results, reports the way you want. So, if I take it a little further, these are again a little bit insight in some of the use cases that we've been and my team and I've been working on over the past couple of years. Applying AI, of course, the AI is applied across, but this is just a little bit insight into what area specifically it was applied. There are several more scenarios, of course, but these are the top ones which are there. First one being in terms of for planning itself, right? How do you make sure your sprint planning is more and more predictable? Because imagine, let's say, a RT release train engineer in a safe kind of a release train. So on an average, you may have 5-6 pods with you, and 5-6 pods, which means 5 sprints going in parallel. Think of it of multiple release trains. You will have almost 20 sprints running in parallel. There would be some amount of dependencies between one pod to other pod, and it's truly a nightmare for a value stream engineer or release train engineer to keep track and figure out whether the team is truly going to hit what they had expected to deliver or they want to slip, right? So a certain predictability helps rather than just relying on the team's gut feel, which is there. So these kind of solutions do help you. Then, of course, is the analysis part, the user story impact, saying, okay, I planned it well, but suddenly we all are very familiar with the scenarios where somebody from the marketing team suddenly gets a feedback on the ground and says, hey, this is the highest priority user story. We want it to be incorporated in the upcoming sprint. Please incorporate it in the PI. I'm sure you've gone through these scenarios, right? So they keep on happening. So interdependencies impact. Again, imagine 20 sprints, something new gets introduced. What is the impact? What are the interdependencies? Which all APIs are getting impacted? What exactly is happening? So that becomes crucial. Architectural hotspots. We all have been through a situation. Of course, I have been many times where early in my career, it used to hit the production. We used to find some scenario there. Of course, ticket used to get raised. And as you dig deeper, you will realize that the solution of it is due to a bad decision made in architecture, and you may have to redesign some of these things. Especially these kind of problems are seen in performance issues. So performance engineering, most often than not, is due to the architectural decisions being not taken correctly when designing it. So these AI can help you make those better decisions as well by identifying those hotspots. Then, of course, the code traceability in terms of where all your code is getting impacted. Your testing integration. Testing integration today, I would say, is one of the spaces where AI is most used to say which all defects, which all test cases are getting impacted. And there are a lot of tools out there which provide these kind of services. And then, of course, self-healing operations, AI ops is a concept I'm sure many of you have heard. So that also is there. But what is crucial in here is that instead of just doing it in pockets, look at it holistically as an SDLC when you are doing or designing that entire software product, and not just in bits and pieces. So if I try and see what is the future that lies ahead, especially in this area, which is AI driven SDLC. This is one of the research that Gartner did. And this is a fairly recent research. It's from October or November 2021, I believe. So just 6 months old, where it says that by 2025, 10% of enterprises that establish the AI engineering best practices will generate at least 3 times more value from their AI efforts than the 90% of enterprises that do not, which means that it's not just using AI for your business solutions, your hardcore engineering needs to be taken a closer look and looked at how you can make it better. So essentially, what I would say is we as software engineers and we as leaders in software industry need to be able to bring in this kind of thinking for our developers, for our testers, for our engineers who are working on creating code. So when you say 93 billion lines of code get generated every year, that 93 billion, if it's augmented by AI, that 93 can be even more. And that 93 can be even better by making sure the defects on it are much lesser. And the code is truly created for the need that it is set out to fulfill. So with that, I would like to thank you for attending the session today. One of the solutions, which is LTI Canvas, is what we used in the use cases that you saw so far. You can feel free to explore it. There are many other upcoming startups which are also working in this area, so you can explore those as well and see if you can bring in some of these concepts in your day-to-day work. Thank you. Thank you so much for listening in. And if there are questions, please put them in the chat window. Thank you again.